Alright, so now it's time for a walkthrough of the server. So yeah, here's the server. Start from the beginning. So what you do is this is a program. It's not an API, right? Because the API makes sense on the client side. Because you kind of have a socket and a server socket, or in other words, a socket that's going to call connect and a socket that's going to call bind. On as far as what the users are interacting with, and that's the same as normal sockets, right? That's the point. So the complicated part is hidden in the server, and the user doesn't interact with it, or the programmer doesn't in this case, because it's an API. So this you just kind of run this as a program, right? It has to run on a machine that's not behind that, and then the clients that are going to use this need to know what the IP address is. So it works very much like a SOCKS proxy. It's currently available, for the Android. There's an Android API for it, right? So it's a proxy object, and you can instantiate a SOCKS proxy that way. So yeah, basically you can specify a backlog if you want. Otherwise, you just need to specify which port you want to bind to, and then number of threads you want to use. Number of threads you can use pretty much whenever you want. I mean, that just changes what you're handling to the constructor of the thread pool. Now, the thread pool is literally, I actually created a class for a thread pool. It doesn't do much. It creates new threads, and you can join them, which is pretty much what you do every time you create threads. So, the idea is make it one line or two lines if you want to wait for them at the end. You just bind to the port, and you get an instance of product constructors. This is where the magic happens. So the server, the main here, so the main thread is doing one thing and one thing only. It is taking in new connections, it is accepting them, and it is passing them off immediately to product constructors, so that the other threads, the server threads, can do all the communication, the handling of everything on those connections. So the idea is that the main thread never blocks, for communication on these, so you can have the server threads block, and the main thread just keep being available to accept new connections. That's the idea. Just keep that availability. You can just keep accepting connections and handing them off immediately, and you don't have to process them. And there's no problem. There's no way that you could realistically. I suppose there's always a way, but realistically, you're not going to overflow your buffer here, because if all you're doing is accepting connections and then handing them off, and then never dealing with them ever again, you have to have a lot of connections coming in all at once in order to overwhelm your I/O buffer there. So yeah, you call accept and you put them into product constructors. Okay, let's go to product constructors. So product constructors is where all the data is. All of the connections wait here in order to be picked up by one of the server threads, which is within the thread pool. So the thread pool has a whole bunch of server threads. Main accepts connections and puts them into product constructors. The server threads are waiting on a monitor that is built into product constructors. It's explicit. And then they pick up that connection, or each server thread picks up one connection, which is a connection to a client. It's using the API. When it's signaled to wake up. So, but what about getting signal to wake up? Well, that's ugly if you try to put it into the threads themselves or anything like that. You want to keep it out of there. So what you do is that you put it all into this product constructors class, and it's just product constructors obviously is just producer consumer structures. So it's like a producer consumer design pattern class. So you can just provide getters and setters. It's also a singleton, but that's not really relevant. It doesn't have to be one. You could make one that's not a singleton, but then I think it'd just be kind of prone to misuse. But anyway, you have your major getters and setters. In this case, it's get pending con and insert pending con, because you're not really setting a pending connection. You're putting one in. It's almost like a queue or something, right? Well, I mean, it literally is a queue, right? So you have a queue of sockets. The sockets are the pending connections. When you insert one, you have to get the lock, you add one, and you signal anyone that's waiting, or any of the threads that are waiting on a pending connection, and then you unlock. So, yeah, that's pretty much how that works. The good thing about this is that from the perspective of the server threads, they do not have to do anything related to synchronization. They just call get this, get that, insert this, insert that, and then it just does it. And you don't have to worry about it, which is awesome. So greatly simplifies debugging this whole thing, which is the big part, right? So the idea is you move it out from here, and it's really easy to debug this. Alright, so on to the server threads. So server threads, the way it works is that you create a big thread pool right when you start up the server before any clients connect. And then as clients connect, your main thread will accept connections and pass them off to one of the threads in the thread pool. It doesn't know which one, doesn't matter. It's just going to put them there, and whichever threads are currently available are waiting in line, and one of them will be woken up and will pick up that connection. Once it picks up that connection, it will do everything having to do with that connection. It will send and receive data to that connected client. The logic for doing so is mostly here in process string. So it will receive a string from the client, it will process it, and then that will do something, right? So you read things from the client, you process them, and then you wait for more things from the client. Now what do I mean by processing? Well, processing means processing it. I apologize if that's not helpful, but what it means is figure out what the command of the string is, right? Because we're just kind of passing the string version of the message here. Figure out what the message type is, right? And then you're doing this by using parse command, and that's in the commands class. We'll get to this. Figure out what the message is, and then take the appropriate action. Appropriate action basically means one of two things. Either you send it to the client that you're connected to as a server thread, because each server thread, like I said, is connected to one client. So either you forward it to the client, or you send it to the server thread, which will then forward it to their client. And as to which thread you're giving it to, that's determined by using the parse address methods here. Also enabling commands. So if it's a connect request, you use the connect version of parse address. If it's connect accept request, or sorry, a connect accept message, you use the connect accept version of parse address. And that's it. I mean, so the only thing that's different between this and this is that you use parse address con accept instead of parse address con, which is great. So yeah, it makes things much simpler. This actually looks kind of ugly, and the reason that is because this was originally a switch on a string. This, the string being the command, the string of the command. It looked much better that way. The only problem is that requires a newer version of JRE, because I had to roll back one version of JRE so that the Android, cause I have a separate Eclipse that I'm using for Android development. That one needed an older version of Java. You can only compile with an older version, so it was finding it a compile time and not a runtime. When I exported the jar for the client, so that was a problem. So I was using them in both the client and the server. Had to remove them because neither the Android or the EC2 server supported the jar that contained the compiled the newer version, compiled in JRE 1.7. So yeah, sorry about that. Anyway, so yeah, you do the appropriate thing depending on whatever the command is. If it's unrecognized command, you just kind of print this little error message type of thing, and that's it. So commands, how do you parse the commands? Well, you're just doing string parsing basically. You have your list of commands here. This is open source, so if you want to add new commands, you can. But this is changing the base protocol, which shouldn't be something you have to do that much, because you can establish connections and you can send data, and that's pretty much what you want the proxy server to do. I suppose you could add authentication if you wanted, or something like that. But that's for implementation. Anyway, yeah, so that's it. You do different things depending on whether it's for example, an accept message or a data message, and that's just kind of because you're sending these same tuples, right? For example, here and here, same tuples, right? Same IP address port tuples, but you're interpreting them differently because here the destination or where you're forwarding it to is this, whereas with the connect accept, because it's connect accept, what you're forwarding it to is actually here. So that's why you have one for con accept and one for con and another for data. So you can change this or reinterpret it however you want later on. So yeah, that's the server. That's good.